Welcome everyone at the second webinar of DYDAS platform. Today I'm going to show you how to work with models inside the platform and how to use your own code to write models and work with data. And also you're going to see the file manager feature of DYDAS platform. So we are here in the home page of DYDAS that we already saw in the first webinar, and now we are going to go to workspace section where, like I said in the first webinar, we can see all our projects and we can edit them. So we take the project that we made in the first video. Yeah, it should be it. And let me check. Yeah, that's it. We have the two dataset that we already created in the first webinar, and with the same data and everything. And now we're going to work with the models. So what are the models? Well, a model is basically a a sandbox of your own code that will be executed inside the DYDAS platform in the DYDAS infrastructure. So we are here in the labs of the model, and we can actually create our own model. We start with a name. We call it simple test. The ID is auto-generated, and we can add here a description, simple model, and we must choose a license, and this is important as we will see in the next webinar for the marketplace part. And for now, we choose a simple Apache license, and we cannot specify. We could also not specify license name and file. So we save, and as you can see here, we created our own model, but as you can see, is empty. We don't have nothing. But here in the script part, we can actually start to write our own code in Python. As well, we can also upload an already existing Python project from our local file system, and basically this src folder will be generated with all the files. Well, for this simple example, we actually write just inside the main, and I'll copy just a simple script that I prepared. So what we have here we have DYDAS package of Python, and basically it provides all the API required to talk with the platform, meaning to download a vector dataset, to upload a file inside the file system of DYDAS, the project file system of DYDAS, and we'll see it later. But yeah, basically through DYDAS package, you have all the features that you can do manually via the user interface inside the DYDAS platform, meaning you can upload a vector or dataset. I mean, you can upload a vector and dataset. Sorry, you can upload a vector file and a raster file inside a vector dataset or a raster dataset. Also, there are all the simple dataset, like I said in the first video. There is, for example, CSV, that are data that are not georeferenciated or referenced by the time. And you can also download inside the sandbox where the model will be executed your own data from the dataset. For example, here you download a vector file via the API. I mean, you do a get vector dataset, and you pass here the full name of the dataset, like there is this one, and you can see all the list of the dataset through this button. and you can see we have only two C region and Italy region. And once you copy this, you can paste it here. Okay, this is just already pasted, but it's exactly what I just copied. As you can see, Italy region 0, etc. So through here you can reference it your dataset, so you can work it work with it via code. And yeah, so you in the there is of course the documentation of the DYDAS package for Python, and I don't know if it's already online, but it will be very soon. So, as I was saying, from API, you can download a vector dataset via the get vector dataset method, and you pass here the full name, that is vector dataset. And here you must pass the APSG. Okay, in our case, it's 4326. And here you have to pass in which format you want the data to be downloaded. Okay, since downloading a bunch of data, uh, you cannot use directly them. Okay, you need it. You need a file where to store them. Okay, since those data could be also huge, so you need a file. And in our case, we choose to download them in GeoJSON. Okay, and the path, so the directory where this file will be saved, is simple the temporal folder of Linux. Yeah, this is just a print. Let's say that we downloaded the file correctly. Now, once I download this file, I can work with it since it will be, for example, a simple file in LSTMP, and will be, for example, some UID.geojson. Okay, since we choose GeoJSON. Now, in this file variable, I have simply a path, okay, a path from pathlib, and I have a file that I can work like I'm in on my local machine. Okay, so you can do transformations. You can use all the available library inside the sandbox. For example, we support TensorFlow, GDAL, and other library Rasterio for enabling the user to work with geospatial data and also machine learning libraries. Okay, so basically in this file you have this a JSON file, and in my case, for this simple demo, I choose to upload this file, okay, inside the user, sorry, the project file manager. That I will explain to you what is a file manager and how it works in DYDAS soon. But for now, assume it's like Google Drive, and you have basically your own space with a bunch of gigabyte available, and you can upload everything you want in every format, and you can download, upload, delete, etc. And of course, it's different from dataset because you don't have all the functionality of the datasets. Dataset is just for for data, and file here in the file system, file manager, you can upload everything you want. So in our case, I upload this file that I just downloaded, so this simple GeoJSON, inside this path on file manager remotely. This is just a boolean that asks you if you want to override the file if already exists in the file manager. But in our case, we don't. But as you will see, it's empty, so doesn't really matter. So this is a simple script, okay? But like I was saying, once you download through the API a file, okay, into JSON, raster, on everything from a dataset, you can work with it however you like, and you can do everything basically you do on your local machine via code, okay? Yeah, so this is a simple example, and I will just save this no, I didn't edit nothing, but okay, I will save and save and run. Okay, and as you can see, the request is taken care from the backend, and basically the platform is now processing our file. Okay, and once the when this code starts, okay, we can see here in the runs, basically the log in real time, of course, when will be available, since it requires some 1 second for creating the sandbox and importing our own code and starting the execution of the code inside the DYDAS infrastructure. In the meantime, while we wait the execution to see the log in real time, I'll talk about the schedule. Well, basically, a schedule is just a repeated execution of the model. Okay, it's like if every 5 seconds or 5 minutes I click save and run. Okay, now we just run a single time. Okay, this code, but with a schedule, you can say, okay, every 10 hours, every like a normal cron expression, as you can see, you can set when execute your code automatically, okay? And you can choose like exactly cron schedule via minute, hour, day, week, month, year, and you can also express your own cron expression here, okay? And you can also set if you want a single execution to start at a specified time. Okay, for example, I want that my execution of the code start at September 27 at midnight. Okay, no, maybe we are, yeah, it's too late for that. But for example, we can do a 28 at midnight. Okay, so yeah, that's basically what is about the schedule, and it's important for those use cases, for example, that generate data each day. Okay, for example, the forecast of the weather, where you can actually download the newest generated uh, weather condition, and you can work with them automatically via code, okay, and get insight information. So we talk about also the file manager, and I'm going to show you what that is uh, here. Okay, so the file manager is the way in which DYDAS allows the user to upload everything from local to remote and from the models to remote. Okay, meaning I can upload from my local file system a file. Okay, I can choose a simple file that's okay, Italy. That is the image that we uploaded in the dataset in the project, if I don't get wrong. But yeah, it's a simple PNG, okay? And here, of course, you can't have all the you don't have a preview, okay? You just have here your file, and you can do, I mean, you can download them, deleted, move or rename, but important, you can use these inside your model, okay? And this is particularly suitable for all those use cases, for example, that work with TensorFlow, okay? Because with TensorFlow you can upload in the file manager a heavy TensorFlow a file, basically your model, and inside the model you can download it from through the API, and you can use it inside the TensorFlow on DYDAS. Okay, and yeah, basically the file manager is really like a cloud storage, okay, like Google Drive, etc. But you have just the functionality to upload and download your files, okay, and yeah, as you can see here in the model part, we can have a little preview of what's going on. Basically, here we can see the model is in running, and this one is not running. Okay, and we can have also a preview here, but just for the license, and if there are last successful executions. We can now check if the runs is completed. Now here also with the live log, okay, that is actually the live log now is in debug mode, so you can actually see all information, but we'll add the possibility to just print log what you really want to see, and but now for debugging purpose it's important. And other than that, you can just download the error log and the output log directly without, of course, when they're ready, in case you want to export them somewhere, okay? And yeah, basically you have all the information on what's going on. And as we can see, we see the print that we did in the model, that is our vector file is downloaded, and this is the path where it's saved. This path, of course, exists only in the sandbox of the model. Okay, basically this model is executed inside a secure environment. It's Docker container that is created at runtime when the execution starts, and yeah, so you can't access directly to this path. Okay, you have to do it via code. Okay, but once you download this file, okay, it's really annoying that every refresh of the log it goes up. It must be fixed, but that's okay. It's a minor issue. And yeah, another thing, yeah, this, as you can see here, you don't have the information where will be stored the file. Okay, so you have to just use what return from this method. Okay, you just know that it will be saved in the path directory, but you don't know, for example, the name of the file. Okay, and differently from the file manager in which you have to specify the file. Okay, as you can see, the model execution has been completed. Okay, so we now go to see the final log, and yeah, we see that the file is uploaded to file stream correctly, and here is the full path of the file system, and we can also download this log. Okay, and we'll have it here, but it's just yeah, a text file. I don't know if you can see it. Yes, it's the same text file with a little more detailed log. I think is yeah, I think is here info, and here we are in debug. Okay, so it's just more information for debugging purpose. And yeah, so what we did actually in the script was to download the file inside this sandbox, this Docker container, create a runtime for your own model, and upload it to your file manager. So we go just to check if is uploaded correctly in the file manager. As you can see, how here you have now a new folder. There is my vector folder, and inside you have Italy region.json. You can now download it, and then you can check if everything is okay. And yes, as you can see, is a GeoJSON, well formatted, and it contains, for example, Trentino Alto Adige, and all the fields that we set in the dataset. So it's exactly like the dataset that the data that we are inside our dataset, and we uploaded in the first webinar. We have Molise, Calabria, etc. Okay, so that's basically how you interact via code with DYDAS platform, and how you can use the file manager and the dataset via code. Um, like I said, file manager is really important in case you want to import inside your own code something that you cannot upload directly on the datasets. Okay, and all those cases are, for example, like I told you, a TensorFlow model or for example, a library, a Python library that is not installed inside the model, and or also unsupported geospatial format, for example, a raster that is not yet supported in the dataset part, but you can work with it via the file manager utilities. Okay. So you have any question? Of course, you can also see in the operation logs everything that we did as operations. You can see we started the model simple model test, and also here you can see the output log, and here you can see the detail of what really happened. You see that the request is being received, accepted, and start the execution. So the sandbox is being created and was being completed. You can also download the log in different times. Do you have any questions? Okay. I guess today we were just fast. Okay, and yeah, I don't think there are other consideration about this part. Just um, that you can, of course, co-work with your own contributors of the project, meaning everybody in the contributors can work with the file manager and the models as well as datasets. An important thing is that when you, for example, want to publish, but we will see later in another webinar, uh, when you want to publish something in the workspace, in the marketplace, sorry, in the marketplace, basically you don't publish from file manager, meaning even if you publish a project, okay, like this one, a scenario project in which you have dataset, models, and dashboard, you will not publish nothing from file manager. This part will forever be private for the project itself, meaning nobody, even if buy your project in the marketplace, can see what's in there. All right, and yeah, basically that's everything that that there is for the models and file manager part. I hope everybody enjoyed this second webinar, and if you have any question, it's your time. Okay, perfect. So I guess there are no questions, and have a good day, guys. Okay, see you at the next webinar. Bye.